Hi, this is Dr. Lineros, and we need to talk about firewalls. One of the things that makes the study of firewalls difficult at times is that you have the conceptual design, in other words, how the firewall systems can be designed, and then you also have the actual layout or the physical installation of where you put everything. I know from the CISA exams perspective, they tend to focus more on the actual physical installation of where things are. However, you can't understand the physical layout of how devices and software are laid out unless you understand the conceptual design. So let's take it in two phases. Let's start with the conceptual design of how the idea behind how you can structure a firewall. It's helpful when talking about firewalls to remember the OSI model. Keep in mind, like I'm a host here and I'm sitting with my application. And for me to talk to your application, I have to go down through the layers, and each of these layers adds something to the data packet. And then the data packet is transmitted, and then it gets unrolled through layers 1 through 7 back to your application until the actual application information is all that's left. And that's how our two applications talk to each other. Keep in mind that anything related to packet inspection is going to be at layer 3. This is where this is where routers are. When we say routers, we're not talking about a device necessarily called a router. It can be that, but it can also be a server that's running a routing software, a routing algorithm. A lot of firewalls run at layer 3, although we do have some that run at layer 5 and even some that run at layer 7. And they tend to probe on that in the CISA exam. I expect you to know, where layer 3 devices are, where layer 5 and where layer 7 is. So if you get confused, you can always go back to this, and it kind of shows you the different layers we'll go through. And everything goes in a U shape. You communicate down, 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 go actually bits going through wire or the air, and then go right back up and unroll back to the application. Another thing, excuse me, is bits transmit into bytes that are frames, and then frames into packets, and then packets into segments of packets, and then the free flow of data. That's what's left after you unroll all these. Let's start with a packet inspection firewall. This works on a layer 3. Basically what it does, exactly what it does, is it inspects the packet. It's the simplest, and it's the earliest form of what is traditionally called a first generation firewall. It only examines the IP address and the port number on the source and the destination. So when a packet's inbound or outbound, it checks the IP address and the port number of anything that's inbound or outbound. And if it's on a don't accept anything from this IP address or don't accept anything from this port number, then it rejects the package. Another thing to keep in mind is that anytime, this is true of all these firewalls, you don't want to have anything in an accept all condition. You want to deny all, and they love to probe that on the CISA. And I expect you to know that all firewalls should be configured deny all traffic, and then you make exceptions for what it is you're going to allow in. You don't want a situation where it's open all and then just deny certain IP addresses. That's a weaker position, although some companies seem obsessed with using it. Basically what a firewall does is it increases granular control of the traffic. It lets you, for traffics that are going inside the network or the ones that are going between internetworks, the way the internet got its name, it basically it lets you set the focus on what IP addresses you're going to be communicating with and what port numbers you'll accept packets from. A data packet, if you picture a data packet, inside of there's let's say it's going this way. The head has the destination IP address and the back has the source IP address. And then one of the things that's in there is the port number that it's communicating through. It's stateless, and by that means nothing is really stored in memory. No previous data packet information is stored. Every single packet is dewy, new, and fresh, so it's completely stateless. It doesn't really remember. This type of firewall doesn't really remember what's come before, or if anything looks suspicious or is being used in an unusual way. This is, again, not necessarily where things are. You notice you would not have just one screening router, but this is an ideation of what it would look like. You have the internet, and then you have devices, and everything's going through one screening router, blocking based on IP address, and/or port. A stateful inspection firewall also works on layer 3. It keeps track of the destination IP address and the destination port number of all packets that leave the business network. So if you have a business network and it leaves, it makes note of the destination, where it was headed, and the port number that it was headed to. And then when traffic comes back, it's checking to make sure that that's the definition of a stateful firewall, one that keeps track of the destination IP address and the destination port number, and it's only going to accept traffic in this stream back from those IP addresses and those port numbers. Keeping track of these truths, basically, it only allows inbound data packets that are responding to a request that we put in to a certain destination IP address or a destination port number. It basically says, hey, I only want to talk to this destination IP address and port number, so I'm only going to accept packets back from that. It stores in something called a state table. This is something that has to be protected in cybersecurity. And the IP address and port number and even sequence number. I try not to get into too much detail, but the sequence number is also kept. And a bunch of other connection-related data like timestamp. It captures that and it calculates, well, based on the timestamp of when these packets went in, what is reasonable for coming back. So it keeps, like I said, it's a pretty intelligent device, a stateful firewall, and then it keeps track of this, tries to make sense of this. One of the things it does, not just this, but one of the things it prevents is a man-in-the-middle attack. Because if you come in and communicate back, it's very difficult to defeat all of these things that are kept in memory and trick the firewall into thinking that it's talking to the destination instead of you. This is, again, a depiction of what the idea of one is. You know, you have a client and you have a server, and the client's out on the internet, and it goes through and checks the state tables. And if the state tables are in sync, then it allows the traffic to come back. If not, it blocks it. And again, it works at layer 3. Circuit level firewall, it works on layer 5. It's keeping track of the actual session information. This is the reason I gave you the OSI model earlier. It works in conjunction with a bastion host, which is basically, there's a subtle distinction between a proxy server and a bastion host. But for purposes of the CISA and for purposes of our class, every bastion host is the same as a proxy server, and every proxy server is the same as a bastion host. The difference is very subtle because the theory is that you can set up a bastion host as a type of a proxy server, and there's other kinds of proxy servers that aren't necessarily as protected as a bastion host. Bastion literally means it's highly protected. But again, that's silly talk. I just want to make sure that if you sit for the CISA, you understand that it considers a bastion host to be a proxy server. It utilizes the same proxy server for all computing and network services. That's what a circuit level does. That's why I underlaid it same, because this is important. And it makes allow and reject packet decisions based on the virtual circuit, the information it collects about this session at the session layer, and that it stores in memory. It uses to allow or reject packets. Each successive firewall I'm talking about is providing more and more security. So here we're not only collecting information about IP addresses and port numbers, but now the actual virtual circuit that's being created is generating information, and it's keeping track of that. Since it monitors and stores session characteristics, it is also considered stateful. In other words, it's keeping in memory information that it will use to determine whether it sends and accepts packets. Again, this is kind of what it looks like. You have an outside host, you have an inside host. It goes through, it goes in, and here in this gateway, it's keeping information that it has captured here at this level. This is a trunk. This is kind of like an abbreviated OSI model. Just know it's the transport model, and it's capturing this information at layer 5. Even though here it's not 5 because they're using kind of a different OSI model. I expect you to know the 7 levels, which is what's tested. Application level firewall, really important if you sit for the CISA, if you sit for one of my tests. It provides this idea of a firewall operates at layer, oops, I'm sorry, I've got a mistake here. This should be layer 7. Sorry. An application level firewall, it's really important if you're sitting for the CISA or one of my tests. This is the highest amount of security. It's checking things all the way up and down the OSI model, including information that the application puts out. So it's checking for even more markers before it allows traffic uh, to go through. Again, for purposes of our class and the CISA exam, Bastion host is the same as a proxy server, but it works with a Bastion host to try to determine what it is that should go or not go into the network. It utilizes a separate distinct proxy server or Bastion host for each application. So each application is going to have its own dedicated Bastion host, which makes it very, very powerful. In addition to application level packets, it can control application services, FTP, file transfer protocol, HTTP, email, telnet, telecommunications networks. It's very powerful. An application level firewall, of course, configuring one takes quite a bit of skill, and you have to know all these different layers and you have to have a very good idea of what exactly is running in your network to configure one of these. But if you do, it's very, very powerful. It also is considered stateful because it's remembering even more information than the previous ones. Excuse me. Again, this is the idea of an application level gateway. Gateway is a fancy word for kind of a router. And you connect the outside host to the inside host, and all of this data is here at layer 7. Again, this is a truncated version, abbreviated version, but all of it's everything that's collected up into the application layer is used to determine whether it should go through or not. A couple of just real quick here, and this will kind of help you. I'm not going to read you all these, but these are some of the advantages and disadvantages of packet filtering, or different firewalls. Packet filtering is the most basic, and then you get into a stateful, then you get into a circuit level, and you can read these on your own. The most advanced, like I said, is the application level gateway. That tends to be what you tend to see on the CISA, that's what they want you to answer when they're asking for the most effective way to block traffic. Be aware, too, there is NGFW, they call it, next generation firewalls. And next generation firewalls work up and down all the layers, and then they incorporate intrusion detection, intrusion prevention, threat intelligence, some AI functioning. I mean, there's a lot. This is kind of the next generation firewall. You don't tend to see this on the CISA exam yet, but it could pop up if you happen to be sitting for it. Just know there are devices that can do an enormous amount besides just this basic filtering. So now let's talk about some actual installations. And in my class, you're just going to be responsible for a couple of them. You're not going to be responsible for every imaginable installation. I've kind of mentioned a Bastion host. A Bastion host is kind of like a reception area. It's like a host. It's a server that all the traffic is going to have to go through. You can't communicate to anybody inside the business network unless you talk to the Bastion host. To the public internet, that's all they see. All they can see is your Bastion host, or if you prefer, proxy server. They can't see anything behind the host, the Bastion host. It's heavily fortified. The BH is heavily fortified, and it's very, very configured to protect against any kind of outside attack. Its operating system is hardened with the very, very latest patching, the very latest version. All unrequired services are turned off. All unneeded ports are turned off. Any unused applications are removed. Any unnecessary administrative tools are turned off. This is what you would be auditing as an IT auditor when you have a Bastion host. You're making sure that it's a very, very hardened device that only, since it's outward facing to the world, that it only has the services that it needs to talk to the outside internet. It has a very low attack surface. It's not unusual for a Bastion host to have all sorts of things, even things, the devices that are not needed are actually pulled out. They don't even have switch ports or hubs or anything. Any kind of port is completely removed sometimes just to prevent accidentally having them having that service on. It's also called a proxy server. It's important you know both names, especially if you're sitting for the CISA, although they seem to be using the word Bastion quite a bit. So here it sits. You got the internet. You have a packet filtering router. So this is a server that's running a routing program, basically something that looks at the IP address of where it's coming from and where it's going. And in this case, the router is looking for traffic in the outside world, and then the destination is going to be the Bastion host. The Bastion host has the public outward-facing IP address for this company. So all the packets that come in go just to this Bastion host. and nothing can talk to the internal network unless it goes through the bastion host. Uh, this is called a screened host firewall. This is the host, and it's got a screen, and everything's got to go through this bastion host. This is not really the firewall. This is just the router that's receiving traffic and sending it to the bastion firewall. It's important now to know kind of what a NIC card is. It's a network interface card. Each NIC has an IP address. That's what actually has the IP address. Your phone doesn't really have an IP address. It has a MAC address, a media access control number, but the NIC card is the actual IP address that's assigned to it. A computer uses a NIC card to become part of a network. That's how everything communicates on the internet, and it's all how everything has to work on the intranet too. Something has to identify itself with some kind of IP address attached to that NIC card. The NIC contains the electronic circuitry required to connect with Ethernet and with Wi-Fi. Anything connected to a network has to have a network interface card. It's also known, it's got a couple of different names here. It's also known as a network interface controller. Some people use that name. It's a network adapter or local area network adapter. Normally they don't play around with this too much on the CISA or my test. I just expect you to know that it's a NIC card. And by the way, I know that saying NIC card is a pleonasm, I think. That's when you repeat the last word twice. This should technically be a NIC, not a network interface card. But everybody says NIC card, so I'm going to continue the tradition. That's what one of them looks like. This is what's on your actual device. What this allows, a NIC card allows for something called a dual-homed firewall. Dual home basically means a device that has two IP addresses. So what happens is you have traffic on the internet. It goes again through the packet filtering router. This is not blocking anything. It's just connected to the bastion host. So it lets a spray of different IP addresses go through here. Here the actual filtering happens. Here's where the actual firewall is. And there's one network interface card, one IP address associated with this side of the firewall, and there's a completely different one associated with this side. And that adds another layer of protection, because that means the IP address of this device is different on the outside world as it is on the inside world. So no one here can even telegraph what the outside IP address is, because they don't know it. As far as they're concerned, this is the network interface card IP address. They don't know anything about this. And the outside world knows nothing about this side. They only know the outward-facing IP address. So it provides a higher level of protection because there's literally two IP addresses on both sides of this. Hang on a second. Sorry, I had a phone blow up. Anyway, so you got two different NIC cards, two different IP addresses. The outside world sees one, the inside world sees a different one, and the inside doesn't know this one, the outside doesn't know this one. Another layer of protection. Now the third, which is, again, if you're sitting for the CISA, it's really important. The screened subnet firewall is what the rest of the world calls a demilitarized zone. And this is the most amount of protection when you're actually installing devices. This is just, I'll show you here a more detailed one, but basically everything is kept inside of this DMZ. It's important to note that a demilitarized zone is just a network. It's just a network where everything in the middle, your web server, your mail server, whatever you put in there, communicates with the outside world and through the bastion host with the inside world. When it's properly designed, it either prevents intrusion or at least it allows an organization extra time to detect and address a breach. So a DMZ, which you tend to see in the real world, is almost everybody of any size or scale has a screened subnet firewall, which is known as a DMZ. It contains all outward-facing servers, email servers, web servers, bastion host, which again is the firewall. It contains everything that's outward-facing. You don't put anything from the enterprise, the internal network, out in the DMZ. You stage information out to the DMZ and then out to the world. This is not really that detailed. This is what it looks like. And once again, you got traffic from the internet going through this router on the outside, and it goes, you have a spray of different IP addresses where it could come from, but it's going into this bastion host. The bastion host executes a firewall, and then when it goes out here, then it has another packet filtering router, which does even more filtering. In other words, you have a router on the outside. This is the outside world, and you have a router on the inside. There are cases where they put different NIC cards on both sides, but usually when you have a router on the inside and another router after you go through the firewall checking whether anything should get to the internal network, that's a lot of protection. But I have known some companies that will, just as a best practice, on the server that's running, that represents this Bastion host, they'll put different NIC cards on both sides. So you have two different IP addresses, which makes an even stronger demilitarized zone. But this is pretty much the world as it exists. Like I said, the original, what I was showing you was kind of that different ideas of the architecture, how you potentially put them together. The three actual installations I expect you to know are the screen subnet firewall, which is the most powerful. It's the one that provides the most amount of protection because you have routers on the inside and on the outside double checking. I expect you to know the dual homed. Dual homed is just a fancy word for there's two NIC cards, one on the inside and one on the outside. And of course that can be combined with the DMZ. And then the last one being the screened host firewall, which basically just has a Bastion host, and it goes through, checks a bunch of stuff, and then lets it go into the internal network. You notice a screened host. I'll let you do this on your own, but the screened host lines up with, come up here, if I can ever make it. It lines up with the packet inspection firewall. The only reason I didn't combine these two is because this is just an idea of where it is, whereas at the bottom here, you have the actual architecture of how things, where you actually put devices. You would use the back side of this presentation for where you would actually put devices. You would use the front side of this presentation for what's the idea and what are we trying to achieve. I hope you find this video useful. I expect you to know firewalls for our final, and I figured that this would be something that would really help you as you study. Hope you have a wonderful holiday, and I'm sure we will talk to you on the next week.